Good afternoon. Today we are going to discuss about the various kinetic properties of colloids. So far we have discussed what is a colloid, which are the various properties of colloids, which are the different types of colloids. So in this class we are going to study in detail about the kinetic properties of colloids. So as you all know, what are colloids? Okay, so these colloids will be having basically three properties, that is kinetic, optical and electrical. Kinetic property of colloids arise due to the movement of particles within the colloidal system. So there are various kinetic properties, we will see each one by one. Okay, so first kinetic property of colloid is, or first we will see which are the important roles of why we are studying this kinetic property. So study of kinetic property is basically, or it is plays an important role in the study of three things. First one is the stability of system, second one is the molecular weight of the sample, and third one is the transport kinetics of colloidal particles. And this transport kinetics includes several properties that relate to the motion of the particle. Now motion may be either thermodynamically induced, example is Brownian motion, diffusion, osmosis, or it may be gravitationally induced, example is sedimentation, or it can be applied externally, example is viscosity, or it can be electrically induced. First we will see what is Brownian motion. So colloidal particles are subjected to random collision with the molecules of the dispersion medium. As a result, each particle show erratic motion. Now what is this erratic motion? The random zigzag motion of colloidal particles is known as erratic motion. Now there is a size limit for these particles to exhibit erratic motion, that is around 5 micrometer. Okay, so when we are observing through a microscope, we can clearly see this erratic motion. Now this motion is referred to as Brownian motion, which is named after the scientist who discovered the motion, who is Robert Brown. Okay. Now as the particle size increases, velocity of particle, what happens to the velocity? Velocity of particle decreases. And similarly, if we increase the viscosity of medium, then it will stop the Brownian motion. So that is Brownian moment. Hope it's clear. Next is diffusion. So diffusion is a process that is directly related to the Brownian moment. So diffusion occurs spontaneously. From where to where? From a region of higher concentration to a region of lower concentration until an equilibrium is attained. So diffusion can be expressed by Fick's first law. Now this property is useful to determine the molecular weight of polymers. First I have said that by studying kinetic property we can predict the, or we can determine the molecular weight. So here the equation is D is equal to RT by 6 pi neta 0 n into cube root of 4 pi n divided by 3 mv, where D is the diffusion coefficient of the polymer expressed in meter square per second, and R is the gas constant joules per mole Kelvin, T is the absolute temperature again in Kelvin, neta 0 is the viscosity of dispersion medium in Pascal second, N is the Avogadro number, and M is the molecular weight of polymer in kilogram per meter cube, and V is the partial specific volume of particle in meter cube. Now viscosity, in this equation we can determine the viscosity by using a capillary viscometer, and V, that is the volume obtained is using the density determination, and diffusion coefficient D is determined by using a diffusion experiment. Now diffusion is generally expressed by Fick's first law. It says that the amount of drug substance dq that diffuses in a time dt across a plane area or a plane surface of area S is directly proportional to the change in concentration dc with the distance travelled dx. So the equation is dq is equal to minus ds into dc by dx into dt. This d value which is obtained from this equation number 2 can be substituted in our previous equation, which is equation number 1, in order to obtain the molecular weight of the colloid. So is that clear? Diffusion. So another scientist named T. Graham found that certain substances diffuse faster and they are known as crystalloids. Example is sugars, salts, acids and bases. And certain substances diffuse slower and they are known as colloidal substances. Example is gelatin and albumin. Next type of kinetic study or kinetic property is viscosity. Viscosity of colloidal dispersion is affected by some factors. Mainly there are 4 factors. First one is the shape of dispersed particle. Second one is the affinity of particles to the medium. Third one is the type of colloid, and last one is the molecular weight of particle. So how does each factor affect viscosity? Let's see one by one. First one is shape of dispersed particle. If there is spherical particles, then it imparts low viscosity to the dispersion, and if the particle is linear, then it imparts high viscosity to the dispersion. Affinity of particles: if linear particles are placed in a medium to which it is having low affinity, what happens? They tend to align into a spherical shape. If they align into a spherical shape, then what happens? Viscosity decreases or viscosity falls. Third one is the type of colloid. Lyophilic colloid are having a viscosity manifold which is greater than the dispersion medium, and lyophobic colloids are having a viscosity which is almost equal to that of the dispersion medium. Last one is the molecular weight of the particle. As we all know, higher the molecular weight of colloid, greater will be the viscosity, and vice versa. Okay, so these are the factors that affect viscosity of a colloidal dispersion. Now, viscosity is an expression for the resistance of flow of a system that you already know, right? Next, Einstein developed an equation of flow that is applicable to colloidal dispersion of spherical particles. What is the equation? Neta is equal to neta 0 into 1 plus 2.5 psi. What is neta 0? It is the viscosity of dispersion medium. Neta is the viscosity of dispersion. Psi is the volume fraction of particle. That means how many particles are present in a given volume of dispersion. Then relative viscosity and specific viscosity. These are the 2 types of viscosity which we have to study. First one is relative viscosity. So the equation of relative viscosity is neta by neta 0 is equal to 1 plus 2.5 psi. And after slightly modifying this equation, we get what? The specific viscosity, which is represented as neta Sp, that is equal to neta by neta 0 minus 1 is equal to 2.5 psi. Neta Sp by psi is equal to 2.5, or what we can say, neta Sp by C is equal to 2.5. I have said psi is the volume fraction of particle. C is the particle in grams per 100 ml of dispersion. So both are terms for concentration, isn't it? So we can replace psi by C. Next, K is the intrinsic viscosity. Now, the neta at various concentration can be determined by knowing neta 0. Neta 0 value is already known. So, for various viscosity, we can determine the neta value. The neta Sp can be calculated from the earlier equation. Now, when the neta Sp by C is plotted against concentration, what we get? We get a curve like this, and when it is extrapolated to infinite dilution, the intercept is known as K. And this constant K is commonly known as the intrinsic viscosity, and it is represented as, the constant K is the intrinsic viscosity. Neta is used to calculate the approximate molecular weight of the colloid. Now, the approximate molecular weights can be calculated by using Markovnikov equation. Which is the equation? Markovnikov equation. What is the equation? Neta is equal to Km raised to A, where K and A are constants. Neta is the intrinsic viscosity determined from the plot, and constant K and A are characteristics of a particular polymer solvent system. Now, from this, what we can determine the molecular weight of the colloid. So, this is viscosity. The next type of kinetic property is sedimentation. Now, why does sedimentation takes place? Due to gravitational force, isn't it? So, the velocity of sedimentation of spherical particle is represented by Stokes law. Now consider a spherical particle of radius r, density rho, falling in a liquid of density rho 0 and viscosity neta 0. Now velocity of sedimentation or velocity v of sedimentation is expressed by Stokes law. What is the equation? V is equal to 2r square into rho minus rho 0 into g divided by 9 neta 0. What is V? V is the velocity of sedimentation. Now, if the particles are only subjected to gravitational force and they will be having a lower size limit, such particles should have a size limit of 0.5 micrometer. We know the colloidal particles are in the size range of nanometer. So, in order to settle these colloidal particles, we have to apply an external force. Okay. So, that external force which we apply is through a high speed centrifuge or an ultra centrifuge. So, instead of G, gravitational force, we are replacing it with another term which is known as the angular velocity, that is represented as omega, and G is replaced by omega square x, where omega is the angular velocity and x is the distance of particle from center of rotation. So, how can we change the equation? V is equal to 2r square into rho minus rho 0 into omega square x divided by 9 neta 0. Okay, why did we change the equation? Because we are studying about colloidal particles. Okay, so there is no gravitational sedimentation due to gravity, so we have to apply an external force. So that is sedimentation. And last kinetic property is osmotic pressure. Osmotic pressure is a colligative property. You know what is a colligative property? These are the property that depends only on the number of particles or solute and does not depend on the nature, chemical nature of the particles. So one such property is osmotic pressure. Osmotic pressure is usually used to measure the molecular weight in the range of 10 raised to 4 to 10 raised to 6. And Van Hoff equation is used for this, where Van Hoff equation is given by pi is equal to CRT, replacing C by Cg by M in the above equation. What we get? Pi is equal to Cg by M RT. This equation can also be written as pi by Cg is equal to RT into 1 by M plus B Cg, where B is a constant for a particular solvent or solute system and depends upon the degree of interaction. Okay, because we are considering several factors. So, we cannot only take the molecular weights, but we have to consider other factors also. So, we are including a constant B. Okay, so that is osmotic pressure. So, these are some of the kinetic properties of colloids. So, we have discussed about the different kinetic properties of colloids. First one was Brownian motion, second one was diffusion, third one was viscosity, then sedimentation and osmotic pressure. Is there any doubt from this topic? Thank you.